We're going to talk about random variables and probability models part 2. Yesterday, in the previous lesson, I guess, we talked about discrete random variables. All right, discrete means countable. So these were random variables like what's the value that shows on a die, or what is this example here in the picture. If we roll 2 dice, what is the sum of each roll? Okay, this is the probability distribution. So you can see that rolling a sum of 7 is the most likely thing to happen, and rolling a sum of 8 is a little less likely, and so on until you get down to a sum of 2 and a sum of 12. It's discrete because there are defined values that the random variable can take on. It can take on 4, 5, 6 whole numbers in this example from 2 to 12. It cannot take on a value of 6.3. There's no way to roll 2 dice and get a value of 6.3. So we call this a discrete random variable. Today we're going to talk about, or in this lesson we're going to talk about continuous random variables. Now these are variables that can take on any value on a certain range, any real number on a certain range of values. Okay, so if we look at heights of American women from ages 30 to 39, there is any height between roughly 58-ish inches up to 73 inches. Any height in between there, a woman could be that tall. Okay, and so we call that a continuous random variable because it could be any real number on the interval, as opposed to just discrete, countable, whole number values. Okay, all right. So let's do some work here. We have talked briefly about the normal curve already, and the normal curve, just to refresh your memory here, the normal curve is symmetric. Okay, and if we have a normal curve for a population, we can say that between -1 and 1 standard deviation away from the mean, so the mean is the middle for normally distributed random variable. So 1 standard deviation to the left or the right of the mean, you're going to get 68% of the data, roughly. Okay, if you go 2 standard deviations in each direction, between -2 and 2 standard deviations from the mean, you're going to get 95% of the data. So the vast majority of the distribution lies between -2 and 2 standard deviations. If you go out to 3, you're going to get 99.7% of the data, okay, or of the population. It's going to be between -3 and 3 standard deviations. Beyond that, it's just incredibly unlikely to find objects in that range beyond -3 and 3 standard deviations. Okay, so because saying number of standard deviations away from the mean is such a is so many words, we have a name for it. We call it the Z-score. Okay, so the Z-score, so we should do this. The Z-score is the number of standard deviations away from the mean. Okay, so a Z-score of 0 is here, that is the mean. A Z-score of 1 is here, 2 is here, and 3 is here. -1, -2, -3, these are all Z-scores. So whenever you hear Z-score, you're thinking number of standard deviations away from the mean. Right? Now, in a previous lesson, we talked about how to find the percent of data that is on certain intervals, but all the intervals that we picked landed on round Z-scores. Okay, so we might have looked at between -2 and 1. How much, what is the likelihood that a random variable goes between -2 and 1? And we could just count up the percentages, right? That'd be 68 plus about 14, so about 82%. Okay, today we're going to talk about how to find values that are not necessarily on whole number Z-scores. Our calculator can calculate Z-scores that are at whole numbers. So you can see here just examples of Z-scores from -1 to 1, -2 to 2, and -3 to 3. And you can see the percentages are given as decimals, so because they're probabilities. So if you look here, 6.68, that corresponds to 68%. All right, and 0.95, that corresponds to 95%. All right, but our calculator will also compute Z-scores that are not whole numbers. So in other words, Z-scores that are between the whole number Z-scores. So for instance, back up just one second. There's 2 steps to finding the probabilities. You're going to find the z-score first in these examples, and then you're going to compute the probability in the calculator using the normal CDF command. And I'll show you how to do that in a second. All right, let's say that we wanted to know between two z-scores. So like, let's say that we wanted to look at from negative 1.5 to 0.5. So maybe we want to know what is the probability that an object chosen is between negative 1.5 z-score and negative 0.5 z-scores. And we want to know this area. Well, we wouldn't be able to figure that out just by looking at the curve over here, right? Because we don't have 0.5 and negative 1.5. So what we need to do is use the normal CDF, and we would just put that into the calculator with the smaller z-score, comma, the larger z-score. The other examples here, greater than and less than, I'll just show you one of them. Suppose we wanted to know what is the probability of being greater than 0.7, right? So maybe we want 0.7. Okay, so here's maybe 0.7. We want to know what's the probability, or what percent of data would be to the right of 0.7, and we could figure that out in the calculator using the greater than. All right, so let's do some examples here. Again, I didn't mention this formally, but the z-score can be found by taking the data point minus the mean divided by the standard deviation. That'll give you the z-score every time, and in symbols that's x minus mu divided by lowercase sigma there. Okay, so let's do some examples. The heights of adult American men can be described by a normal model with a mean of 69.2 and standard deviation of 2.8. What's the probability of the randomly selected adult American male? Okay, and so we're looking at what is the probability that you randomly pick a male and their height is between 65 and 70 inches tall. So the first thing that we're going to do is find the z-score. All right, and so the z-score, this is, back up a second, this is between, okay, so we're going to follow the between over here. And so we're going to find the z-score for each one. So we're going to look at the z-score of 60, so that would be 60 minus 69.2, all divided by 2.8. That gives me a z-score of negative 1.5. All right, and then we're going to go find the other z-score here. So z equals, data point is 70, should be 65. Apologies, so 65 minus 69.2. And then we're going to go z-score of 70, so we'll go 70 minus 69.2 divided by 2.8. That gives you a z-score of 0.29 approximately. Okay, 0.29. So then in your calculator, you're going to go normal CDF, negative 1.5 up to 0.29. So just to give you a visual here, we're looking at negative 1.5, so that would be right over here, up to positive 0.29, which would be just to the right of 0 up here. So we're trying to figure out that probability, okay, between negative 0.29 and, or sorry, 0.29 and negative 1.5. So in your calculator, here's the commands you're going to use in your calculator. You're going to hit second, and then the vars key. Second vars, and then you're going to go normal CDF. Let's get out of the glare there. So normal CDF. You're going to go negative 1.5, comma, 0.29. Hit enter, and you get 0.547. So your probability is equal to 0.547. Right? Now, let's look at a greater than one. So what's the probability that a randomly selected male is over 6 feet tall? Well, first of all, we need to convert feet to inches. So 6 feet is 72 inches. So there's our data point. So to figure out our z-score, we're going to go 72 minus 69.2 divided by 2.8. You get a z-score of 1. Okay, so we could just look at the graph, but just to get a little bit more practice, we'll use normal CDF. So in the calculator, we'll go normal CDF. And we're going to go, so we're looking at the greater than line. So in greater than, we're going to go the z value, comma 5. And what that does is it gives you the probability of, probability between 1 and 5 standard deviations away from the mean, which is basically 0. Okay, so from 1 to 5, you get 0.159 for the probability. All right, let's jump to less than. Shorter than 5 feet 6 inches. Again, we need that in inches, so that turns out to be 66 inches. We'll find our z-score is 66 minus 69.2, all divided by 2.8, and you get negative 1.14 for the z-score. And again, in your calculator, you're going to go normal, CDF, just so you've got it in your notes. You're going to go, this is less than, so it will be negative 5, comma, negative 1.14, and you get for that 0.127.